Welcome to the session. Today we are going to discuss the question bank related to the topic mathematical logic and predicates. So question bank consists part A, part B and part C. So in that we are going to take up different parts. So first we are going to concentrate some of the questions in part A, then we go for the questions in part B, and then we go for questions in part C. So like that. So here in part A, the very beginning question is determine the negation of the following statements. So here these are the two statements are given, three statements are given. We are going to find the negation of these statements. So first of all, for finding negation of the statements, so we are going to write this into the symbolic form. Then afterwards we are going to take the negation and once again we are going to convert into the sentences form. So in that, the first we are to try to write in symbolic form. So for that we are going to write first John will take job in the industry or go to graduate school. So I am going to consider the preposition P as John will take a job in industry, and Q is another preposition, John go to the graduate school. So if I am considering the preposition in this manner, then the A will be written like this. So P or Q, the given statement are going to be written in a symbolic form as like P or Q. John will take a job in industry or go to graduate school. So this is the symbolic form of this. Now we are going to take the negation of this. We are going to take the negation of this symbolic form. So that is nothing but negation of P or Q. So which is equals to negation P and negation Q. So this we are going to write in sentence form. That is John will not take. So John will take is P, will not take a job in industry is negation P, and so we are going to write and not go to the graduate school, not go to the graduate school. So we are going to write the negation of the given statement. The negation of the given statement is this. And the second one is James will bicycle or run tomorrow. So here James will bicycle tomorrow, P, and Q is another statement as Q as James will run tomorrow. So here we are going to write in the same manner the symbolic form as P or Q. So James will bicycle or run tomorrow. So this I am going to remove this. So then this I am going to write in a symbolic form. Once again taking the negation, and we are going to get the same negation. So here the negation of the statement is James will not bicycle and not run tomorrow, So this is. And the third one, if the processor is fast, then the printer is slow. So P we are going to take it as the processor is fast, and Q we are going to consider it as the printer is slow. Then the given statement can be symbolically written as if P then Q, and which is equivalent to negation P or Q, Then we are going to write the negation of this. The negation of this is just a negation of negation P or Q, So it is double negation, which is nothing but P and negation Q. P is nothing but the processor is fast and the printer is not slow. So this is the negation of the above statement. Now go for the another problem. So find the principal disjunctive normal form of this using truth table. We are going to find the principal disjunctive normal form of this. So for this there are three prepositions are there. One is a P, Q, R. So there are 2 power 3, that is 8 possibilities we are going to get. 8 possibilities we are going to get. So those 8 possibilities are, let us say, 4 truths we are taking, and next 4 false we are going to consider. 4 false we are going to consider. And in P, and these are the 8 combinations we are going to get the truth values of P, Q, R. So first P, we are writing 4 truth values and 4 false values, and Q is 2 truth values and true false value, like that alternatively, and R is true false alternatively we are going to write. So there are 8 combinations, different combinations we are going to get in this order. Then P and Q we are going to calculate. So P and Q is nothing but a true, just these 2, and operation we are going to perform, then it is true, then this is also true, then this is a false, then this is a false, and it is a false, and it is a false, and this is a false, and this is false. And now let us go for the other one. See, this is a QRR. So just we are going to concentrate on these 2, QRR. So it is a true, then it is a false, then it is a true. So this is also true. We are going to have true or false is a true, then false is a false, then true is a true, then this will be once again true, then it is a true, and then this is false. This is false. So any one of the truth values of Q or R is true, then obviously it is true. So first one is true, second one is true, third one is true, fourth one is false, fifth one is true, sixth one is true, seventh one is true, eighth one is false. Now the ninth one is negation of P. Negation of P is, we are going to take it as this, we are going to consider it as false, then this is false, first 4 are false, so we are going to get false, and then we will have all our truths. All our truths we are having like this. Now negation of P, R. So here negation of P, R. So the first one is true, and then R is second one is false, the third one is true, and the fourth one is false, and the fifth one is true, and then the sixth one is negation of P, which is also true, and then the sixth one is also true, and then this is false. Now we are having either P and Q, negation of P, R, and next Q, R. So from these 3, we are going to find what is the R between. Then we are going to get the first one is true, and here it is false, and here it is true, and here it is true. Subsequently we are going to get true, and the next one is this is also true, and here it is false, and then this is also true, then this is also true, and then this is also true, and then another one is false, this will be false. Now we are going to consider all the truth values into the consideration. So this one, and next this one. So we are going to consider all the truth values. So the first truth value is, so we are going to take it as P and Q and R. The first one is, and the second one is R. The second one is P is the same, and Q is the same, and R is false will be there. We are going to take it as negation of R. This is for second one, and the third one is P is true, and Q is negation of Q, and R is then it is false only. This is true only. So I am going to have let us this. This is the first 3 terms, and next the remaining, this one we are going to concentrate. So R, then negation of P and Q and R, then the next one is negation of P and Q and negation of R. Then the third one is R. Then we are going to have the third one is total there are 6, 1, 2, 3, 4, 5, and the sixth one is negation of P and negation of Q and R and R. So these are the principal disjunctive normal form, sum of which is nothing but the sum of the products. So any repetitions will be there, then we are going to remove that. So here negation of P, Q, R, it is not there, negation of P, so negation of P, negation of Q. So we are having, this is the principal disjunctive normal form by using truth table, Now let us have the another one is, we are going to concentrate the show that R and P R Q is a valid conclusion, and from the premises are given as like this. So here, so we are going to concentrate all these premises and we are going to consider AND operation between them, and we are going to say the R and PRQ is a valid conclusion. So for that, let us concentrate the first. This is if P then M. So we are going to consider this is the given premises. So we took the first premise as P to Q, P to M. Then we are going to write the same thing, the equivalent form, that is nothing but the contrapositive. So negation P, M and negation M, then negation P. So both are equivalent, so we are going to take like that. And next we are going to consider another premise. So negation of M. Then this is the second premise, and now by using these two, and we are going to apply modus pons, then we are going to get negation of P. That is nothing but just we are going to write it as P to Q. Then again, if P is there, therefore Q will be there. So this is the modus pons. So here from 2 and 3, we are going to get negation of P. So which is also true. Then we are going to consider another premise, PRQ. So let us consider that as 3, the 3 premise, and now we are going to consider the equivalence of that. So which is nothing but if P then Q is equivalently written as negation PRQ. And the same way we are going to write this as like this. So here double negation of PRQ, then it will become so PRQ, which is in fifth step, whatever we have, the same thing we are going to write equivalent form. Then another one is, then we are going to consider what is this from these two, 4 and 6, apply the modus pons, then we are going to get Q. So once you are going to get Q, then I am going to take the remaining premise as 4, then I am going to get if Q to R. Then I am going to combine 7 and 8, apply modus pons once again. I am going to get R is true. R is true, and PRQ is also true. Subsequently, the whole thing by using the rule of conjunction, we can say that it is true. So this is the way that we are going to do the first problem. And the second one is R to S can be derived from the premise if P, if Q, then R, S, and negation of R, P, and Q. So from that we are going to do this. So here let us consider the first one is negation R, P. So this we have to consider. And next, moreover, we are going to take the equivalent form of that, and then we are going to consider the equivalent form is nothing but R to P. Then we have to consider another premise. So it is nothing but R, another premise. So where is that? The R is, that means here only limited number of premises are there, which is not sufficient to prove, so that we are going to take one assumed premise. So that assumed premises are, then we are going to apply 1 and 2 and 3 operations we are going to perform. Then we are going to get P, which is by applying modus pons. Then we are going to take another premise, P to Q to S, and then once again applying modus pons, then Q to S we are going to get. So now we are going to consider the remaining Q will be there, that we have to consider. So Q I am going to consider and apply both Q to S and Q, then I am going to get yes. I am going to guess yes. So now yes is there, and the next one is yes is there, and the next I am going to get like that. So now I am going to find out R to yes. Here it is a mistake, and R is I am having from the equation 3, and yes I am having from equation 8. So this I have to write like this. So if P is true, then Q is true, then automatically if P to Q is also true, if P then Q is also true, then we can say that if R then yes is also true. Okay. So this is the way that we are going to do the problem. And now let us go for another problem. Let us consider, show the following premises are inconsistent. So inconsistent means then we are going to consider, that means whenever we can say that if P and negation P is true, then that is known as a inconsistency of that. So for that we are going to prove the following premises, we are going to convert into the symbolic form, and after that we are going to verify whether it is a inconsistency or not. So for that, so Jack misses many classes. So and through the illness, then he fails. I am going to consider this as P and this as Q, this as E, and this as yes. He fails in high school, yes. And the next one is Jack fails in high school is already considered as yes. And the next he is uneducated. So this is he is uneducated. Then the third one, if you are going to consider, Jack reads a lot of books, which is already we considered, then he is not educated. So this is also considered. Then Jack misses many classes through illness, and that is also there, and and a lot of books, reads a lot of books. So that we have to consider. As another premise. So that is A. So here, so up to here 1, 3, and Jack misses many classes through illness, and a lot of books is also going to be considered. That is a D, and we are going to take by assuming the premises in that, and we are going to convert this. Okay, D is this. Now let us go for first one is if E then yes. If Jack misses many classes, then Jack fails in high school. So that is, so the statement, the sentence A can be written as if E then yes, and B can be written as if Jack fails high school, then he is uneducated. So that is going to be written as yes to H. These two we are going to combine. Then we are going to get the third one. And if Jack reads a lot of books, this is there, we are considering it as A. So what we are going to get? If A, then he is not uneducated. So A, then negation of H. And the remaining, we are going to consider E and A. So these are the four sentences we are going to convert into a symbolic form. Now we are going to verify, and operation we are going to perform on these premises. Then we are going to verify whether it is true or not. So for that, let us give for, this is the given one, and this is also given one. So E to S is given premise, and S to H is also given premise. So then E to H, we are going to apply rule of syllogism. Then we are going to get this. And the next, another one is negation of H. Then taking the contrapositive to 3. Then we are having like this. And then the another one is another premise. This we have to consider. This is also over, and this is also over. This we have to consider like this. And then from this A to negation H and negation H to E, then negation E, then we are going to apply by hypothetical syllogism. Then A to negation E we are going to get. A to negation E we are going to get. Then once again by taking the contrapositive of 6, then we are having this is E to negation A we are going to write. The equivalent form we are going to consider. And then once again we are going to take the equivalent form of this is I am going to get like that. So which is nothing but once again taking negation is common, I am going to get this is the equivalent form. Then already it is given E and A is true, and here I am getting negation of E and A is true. E and A is true, negation of E and A is true, which is meaningless, which is not true. That means the given premises which are inconsistent, So let us go for the another problem. Define a conditional proportion and a logical equivalence with a suitable examples. So what is a conditional proportion? If P is a proportion and Q is a proportion, then if P then Q is known as a conditional proportion. So the conditional proportion, if I am going to consider, so the conditional proportion truth table is given here. And now we are going to say that this is going to be equivalent to another one. So whenever two compound proportions are said to be equivalent, then one is derived, one is obtained from the other by using logical implications. Then we can say that they both are equivalent, or else by truth table also we can say that if the truth values of P and Q, we are going to get the same truth values of those compound proportions. Then also we can say that both are equivalent. So for that, suppose here if P then Q is one compound conditional proportion, and next the equivalent form, let us say negation P R Q. If you are going to find, then both are identical. Then we can say that these two are equivalent to each other. So which is equivalent to negation P R Q. So like this we can say that two compound proportions are equivalent to each other. Now let us go for the another one is, see here these are the two compound proportions are given. So we are going to prove that one is logically equivalent to another one. So that means any one you consider, and we can reduce by applying appropriate methods and get the remaining. Then we can say that both are equivalent to each other. So here for that we are going to consider P negation, the solution of 1. So I am going to consider what is this is. This is going to be this I am going to consider. This is I am going to take it as just taking negation out. Negation PRQ. Then we are going to consider it as. Okay, let us go for the another one. So I am going to consider this is PRQ, and okay, PRQ are negation P and negation Q and R. So I am going to get a PRQ R. Then if I am taking negation, then this will become PRQ. Then this will become PRQ. Then PRQ are this, and then and this is. So what we are going to get, this is a true, and this thing we are going to get. So true and this, automatically we are going to get the same. So we are obtained the another one, right hand side one. So we can say that both are equivalent. equivalent. In the same manner, we are going to say, take the other example. Also, we can prove that from that left hand side, we are going to get the right hand side value. So we can say that both are equivalent to each other. Both are equivalent to each other. Now, this is, let us go for explain the term tautology and show that these things is a tautology. So we are going to explain the term tautology means for all possible truth values of P, Q, R. We are going to get the compound proportion, whatever the compound proportion is given, that is true. Then we can say that it is a tautology. It is a tautology. So for that sake, for that reason, we are going to find all the possible cases, for the given compound proportion, which is given as if P, then Q, then R, then once again conditional, the remaining things we are going to prove it as a tautology. So for that, let us, we are going to see all possible combinations. Let us say P, Q, R. So these are what are the possible combinations? Let us say true, 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 true. And the next one is false, 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 false. So 4 possibilities: true, false, true, true, and false, false. Then once again true, true, and then false, false. So now this is a true, false, then it is a true, false, then it is a true, false, then it is a true, false. These are the possible combinations. Now we are going to verify. This is the first one. If P then Q. If P then Q. So once if you are going to consider true, then it is false, then it is true, then it is true, then it is true, it is false, it is true, it is true. Then P to Q, then R, then R. So once again, we are going to this one into this. So it is true, then this is also true, this is also true, it is false, it is true, this is also true, this is also true, and this is also true. Then this, let us call this as 1, and then this we are going to call it as 2. Then P to R, we are going to take it as P to R. So P to R is true, false, then true, then false, then true, then true, then it is true, then it is true. So P to R I am going to get. Now P to Q, then P to R, then P to R. So this is a 2, this is a 2. So it is a 2, then P to Q, then it is true, then it is also true, then this is third one is true, then the fourth one is false, then all are true. 1, 2, 3, 4. Then once again 1, 2, 1 implication, 2 is. So here 1 to 2, this is true, and this is also true, this is also true, false, false is also true, then the remaining all are trues. So all possible combinations of the truth values of PQ are the given compound proportion. The given compound proportion are true. So we can say that it is a tautology. It is a tautology. Then the similar way that we are going to find out what is the converse, inverse, and next contrapositive. What is the converse, inverse, and contrapositives that we have to consider. So here, let us go for. We are going to take the implication. Let us say if P to Q is there, then what is the converse of this is? Converse of this condition is, then we are going to write Q to P. So this is converse. This is next inverse we are going to consider. Negation P, then negation Q. Then contrapositive if you are going to take. Contrapositive. Then this is a negation Q, then negation P. So these are the inverse, converse, and contrapositives. in this manner we are going to get. Now, let us go for the first one. P to Q to R. P to Q to R. So, while we are going to consider this, then we are going to take it as, so the conditional, first one is converse if I am going to take, converse if I am going to consider, then what we are going to get? Q to R, then P, then P. This is converse. Then contrapositive if you are going to consider, contrapositive. So the contrapositive is negation of Q to R, then negation of P. And then another one is inverse. Another one is inverse. So inverse is nothing but negation P to negation of Q to R. Q to R. So like this we can do that. Or else if you want to simplify also we can simplify this. We can simplify this. Simply negation of, what is this? Negation Q, R, R. So this is negation P. Next negation of, then going negation inside, then double negation is Q and negation R. And negation R. So I am going to write the equivalent form, inverse either we can write or the simplified version we can write like this. In the same manner, this is also we are going to write negation of negation Q, R, R, then negation P. So it is a Q and negation R, then negation P. So like this. So in the second, this is the first one. And the second one, if I am going to consider the second one, then the inverse is, converse is. So it is Q to P and P to Q. Converse. Then the contrapositive. The contrapositive is negation Q, then P and P to Q. This is a contrapositive. And then the inverse is, then the inverse is, then we are going to consider negation of P and P to Q, P to Q, then negation of Q. So this is the way that we are going to find out the inverse, converse and the contrapositives and the contrapositive. Suppose next another one is show that SRR is tautologically implied by this. Tautologically implied by this. So we are going to have PRQ and PRR and QRS, which is implies SRR. SRR. So that is we are going to consider, so first the given premise, this is the given, and then we are going to write its equivalent form. We are going to write its equivalent form, and next we are going to consider another premise. So this is another premise, Q to S. Okay, two premises we are consider here. Then once again we are going to take it as the combining these two. So negation P 2 and 3. So what we are going to get? Negation P to S. Negation P to S. That is by applying rule of syllogism. If P to Q, then Q to R, then what we are going to get? It is a P to R. It is a P to R. In a similar way, from negation P to Q, Q to S, so negation P to S we are going to get. And now, for this we are going to take its contrapositive, then once again we are going to get, and now we are going to consider another premise. Another premise is this, and we are going to consider, see, negation S to P, P to R, by using rule of syllogism, negation S to R we are going to get. And the equivalent form, negation S to R is negation of negation S, R, R. So we are going to take like this. So which is nothing but SRR. SRR. That is the equivalent form we are going to have. So like that we can get the final output. And now let us go for the other R or yes is a valid conclusion from the premises. The given premises are these, and from these we can say that the R or yes we are going to obtained from this. So, okay. So here let us consider the first one is, this is the given premise we are going to consider, and take the contrapositive of this. So negation H, then, and we are going to consider the, this is the another premise. This is the another premise, not contrapositive. Two different premises we are going to consider. So P to Q and Q to R. So combining P to R we are going to get. So we are going to combining two premises and the rule of syllogism. Then we are going to get this. And now we are going to consider another premise. So CRD. Next apply 3 and 4 and apply modus ponens. Then we are going to have this is. So A and negation B. We are having. Then once again the remaining things we have to consider A and negation B. The fourth one what we are going to have, this is the fourth one, and we are going to consider the given premise. So from this, so here P is there and P to Q is there. So modus ponens is nothing but Q is true. So from that C to A and negation B. If A and negation B to R are yes, then the resulting we are going to get R or yes. So this is by using modus ponens. So like this we can prove the problems, some of the problems, and now we are going to solve some of the problems in the next session, and which is pertaining to the first module, that is a mathematical logic and predicate. So with this I'm going to conclude this. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.